Good evening. We'll start with this 5.15.9 question. So this is, we have to find 1.75 P 45.5. First with uniform distribution of depth. In this case, you can clearly see that our value is going to be definitely beyond one integer, right? So we are starting from 45.5 and going till I think 47.25, right? So we will have in between 46 and we will have 47 in between. So this 1.75 P 45.5, first we'll write it as 0.5 P 45.5, and then 46 to 47 we'll just have P 46, and then we will have from 47 have 0.25 P 47. Now we'll use uniform distribution of depth, UDD. UDD were 1.75 P 45.5 will just become this. We'll say 1 minus, and in Q we have the formula, that is T minus S being 0.5 Q 45 upon 1 minus of S, that would be 0.5 into Q 45. It's a formula. P can be written in terms of 1 minus Q. I'll do that, but here I'll just write P 46, and this will be 1 minus of 0.25 Q 47. Now these values we can take from AM92 table. AM92 table, after ELT 15 we have AM92. Okay, so after ELT 15, if you go further, we will have AM92 table. In this AM92 table, we will first look for Q. So see, first of all, when you reach this AM92 table, if you go further, you will have first L values. For now, we'll just ignore the brackets. I will be explaining what is the use of those bracket signs. We will be talking about that later, but first we will just see L without the bracket one. So we'll be ignoring those two columns. We are just talking about this column. Okay. So L value is given to us. If we go further, 2 pages of L, then we go further, we'll have D value, 2 pages of DX, and if we go further, we have Q. We want Q45 and Q46, Q47. So Q45, 46, 47 down here. These are the only two columns we are interested in. Okay, so bracket 1 minus, we'll have 0.5 into Q45, 0.001465 on 1 minus of 0.5 to then for the next one, P46, we'll just write 1 minus Q46. Just give me 1 minute, okay? I'll be back. Okay, so 1 minus Q46 into, we will have 1 minus 0.25 of Q47. So that would be 0.001802. Bracket close, and this is our value, 0.997197. Okay, what about force of mortality? Okay, so this is CM, constant force of mortality. What will we say? 1.75 P 45.5 will be equal to Okay, here this will become P45 raised to 0.5, P46 and P47 raised to 0.25. Again, you can use this P values in terms of L, but 1 minus Q would be easier for us to write. Okay, so we can write them in terms of 1 minus Q, 45, 46 and 47. So 1 minus Q45 0.001465 bracket close raised to 0.5 into 1 minus Q46 1622 bracket close into 1 minus Q47 0.1802 raised to 0.25. So we have 0.836. Okay, I've made a mistake. In Q46 I did not write 2 zeros here. Just edit. I have 2 zeros here. Okay, so 0.997197. So you can see they are nearly same. Both of these is giving me nearly the same value, but does not mean they are exactly the same. There will slightly be a difference. It just happens that in these particular cases we do not have much difference. Okay, they are nearly the same value. Okay. Methods definitely a lot different. Okay, uniform distribution depth and constant force of mortality. Now we'll go to chapter 16. Okay, chapter 16. See,
Sir,
in chapter, yes.
Sir, why can't we directly write as 1 minus 1.75 Q 45.5 and from there we can.
Here you can definitely.
Yes.
It's just why
I'm
to
getting
write more things when this is what the formula is, right?
I'm getting a wrong answer, sir. First one,
So in the
under
first
UDD.
one,
Yeah.
What check the calculation.
Instead of writing in P and then we have to Q.
Instead of P, I'm not writing Q. I'm writing 1 minus Q. Right? See, first formula 1 minus of this. The second formula is 1 minus of Q46, right? Sir,
no, I'm asking the first one 1.75 P 45.5. Why can't we write as 1 minus 1.75 Q 45.5? Is that right, sir?
Because that will be of no use. If we write it as 1 minus of 1.75 Q 45.5, this is correct. But what do we do with this then?
Then we can split that into integer parts now, sir.
Q does not get split. Only P gets split. Okay, so we can only split P into different multiplications. We cannot split Q. Okay.
Okay.
So that is the mistake. Okay. So only P follows the principle of consistency. That means our n plus m px can be written as npx into mpx plus n, right? Q does not follow this. So we cannot split Q, we can only split P. Okay. So life assurance, I think last time I told you about the difference between insurance and assurance, right? So in life, we have assurance. Why? Because we say you will get at least that much amount if there is a loss of life. So the policy holder, okay, usually whoever life is insured, the family would get the money. The family gets at least a assured value. So if you say there's a life insurance of 1 lakh rupees, the family gets at least 1 lakh rupees, sometimes more than 1 lakh rupees. It depends on different kinds of policies. Okay. So whenever we are talking about different kinds of assurances, we'll be talking about a few different types of assurances. First, the policies or the type of assurances that we call assurance contracts. Okay, assurance contracts, we will call them as products, because we are looking from the point of view of the company, and for company these policies are nothing but the products. So what are the different kinds of products the company produces? Products. Okay, then we'll say what does that mean. We'll talk about the meaning, and we will talk about the purpose of these products. Okay, I'll just make lines. Okay, let's keep a little bit more space for the meaning, and for the other two we don't need as much space. Okay, so the first product that we'll be talking about is life assurance, whole life assurance. Okay, so we'll say whole life assurance. Okay, in this we say, now see, we talked about this whenever we are talking about the payment given when life is lost, we call it as either benefit or we will call it as sum assured. Okay, so right now we'll be writing it as benefit. So benefit is paid on, we'll say, individual's death, or let's say policy holder. Okay, policy holder's death. Okay, there is no condition here. Okay, there is no condition here. Whenever the policyholder dies, the family will get the money, whatever money was promised, whatever benefit was promised. Okay, so we'll talk about the purposes later on. First, let's talk about different types of products. The second product is term assurance. Okay, second product is term assurance. In term assurance, we say benefit is paid on death, is paid on death, provided the death occurs during specified period called term of contract. So we have a contract here. This policy is nothing but a contract. So in the specified term of that particular contract, if the policyholder dies, then the benefit is given. Otherwise, the benefit is not given. Okay. The third one is pure endowment. Yes, Utkarsh.
So like in the contract, it is like a clause or something, like it is written ki you have to die like within 20 years, then we'll pay. Or...
It will not be saying that you have to die within 20 years. It says if death occurs within 20 years, then this much benefit would be paid, right? Okay. This is the language we'll be using. Right?
Sorry, yeah, my bad.
It's okay. It's just funny. Yeah.
If it goes beyond, like he suppose dies after 20,
yeah,
then he'll not get anything.
Nothing. Yes.
Okay. Thank you.
Okay, so that would be specified in the contract. So by any chance, if you have some policies lying around, of course, most likely your parents must have some kind of life insurance policies. So just look at the contract. So you will have a lot of pages. So it specifies a lot of situations, because usually these cover a lot of different things. Sometimes what happens is not only life lost, but also sometimes some kind of disabilities are also covered. So by chance you had an accident and now you're disabled, you cannot work. So in that case also many times these policies cover a lot of different things. Okay. So they will specify a lot of terms and condition, in what condition, what type of death, what condition, specifically, if there was an accident in which it is proven that the driver, it was driver's fault, or maybe driver was drunk, then in that case the insurance policy would not cover. So there are a lot of clauses given. Okay, lot of conditions given, lot of clauses given, in which they would cover a certain amount or they would not cover a certain amount. Okay, so a lot of different things are specified, but yes, this is the basic crux of that policy. Whole life, then term, we have pure endowment. Okay, pure endowment assurance. In pure endowment assurance, we say benefit is paid at the end of a fixed term provided policyholder is then alive. In this pure endowment policy, we are not taking death into consideration. We are saying if the person dies within those specified term, then the policy does not pay anything. Okay, but if the policyholder survives, then a certain amount is paid. Okay, then we have endowment assurance. Endowment assurance is term assurance plus pure endowment. Okay, so it is combination of the above two policies. Okay.
Sir?
Yes.
Why would they pay if the person's still alive?
Because that is what the contract says. Okay, so you might say that what is the purpose of this? Okay, so this is usually done if you are investing money for some purpose. Okay, so maybe let's say for marriage purposes, if you are investing. Okay, so in that case, if the purpose is that if the person is alive, then you need money, then you will be doing that. Maybe if you know that after some number of years, let's say after 65 years of age, or maybe 75 years of age, you know that you would require some kind of assistance, let's say, because of course because of age, you will not be very well in terms of going around and stuff. So maybe you will require a nurse for taking care of you, so you will be keeping money for that. So if you survive, then you require that money. If you don't survive, you don't require that money. Correct? So we keep such kind of policies. So there might be many different reasons, right? So endowment, then you have deferred. Okay. Deferred benefit. Deferred can be any different kind. Deferred whole life, deferred term, deferred pure endowment. There can be, actually pure endowment is sort of deferred, but anyways, there can be many different kinds of deferred policies. But here benefit is deferred for a period. Okay, so in deferred, what happens is we'll say I'm starting to pay the premium now, but my policy's benefit starts after, let's say, 5 years, or let's say 10 years, or something like that. Okay, so in that case, what happens is, today I'm paying amount, but my life is not covered in this particular case. But after 5 years, the policy actually starts. Okay, so we'll talk about what are the benefits, what might be the reasons people would do this. First, let's talk about whole life assurance. Usually, whole life assurance can be taken at any age, right? But what happens is, at a certain age, after a certain age, the person might have a lot of money and might have in near future would need to pass on that money. So one of the good way of investing, making sure that as soon as the person dies, the children or wife or whatever gets a certain amount, exactly a certain amount, is using whole life assurance. This is one of the way of investment, such that a person, after the death, usually after a certain age, if person dies, person gets the money. So this is usually used in sort of an inheritance case. Okay, inheritance. So if a person, usually let's say age now is 60, within a few years, maybe 20 years, 25 years, the person knows that he will have to pass on the money at age 60. Let's say the person is retired, gets a lot of money, rather than keeping that money and passing it on directly to their children or wife or whatever, they make a whole life assurance policy. One of the reasons why a person would take whole life assurance and not just pass on that money or invest it somewhere else and pass on that money is because in this, the benefit would be fixed. If I take a whole life assurance policy of 1 lakh rupees, okay, the amount will never be lower than 1 lakh rupees, right? The amount paid will always be more than or actually equal to that amount, right? So there is an assurance that that much amount will definitely be given. So therefore, whole life policy is more like a inheritance case. The purpose of this is inheritance. Of course, it can be taken at any time in life, but one of the main reasons people take is inheritance. Okay. Now let's talk about term assurance. In term assurance, there is a condition, right? Benefit is paid only if a person, the policyholder, dies within that certain time period. So policy is usually, let's say, for 20 years or 25 years or 40 years or 45 years, whatever. Okay. So if the person dies within those years, then the family gets paid. If the term ends, then no amount is paid, and the person is alive, then no amount is paid. Now, can you tell me where would, or is it fair? Is it fair to pay for nothing happening? Is it a good kind of a policy? Term assurance?
Sir, if I take a home loan, and I feel that if I take a home loan,
yes,
and if I feel that the liability has to be covered for some 20-30 years, so at that time I would take a term assurance policy.
That seems good. Okay. So you are basically keeping a security in case you are not able to pay off the home loan because of death, right? So the reason for term assurance, okay, the reason for term assurance is security. Okay. But not exactly home loan, but you can imagine if a person started a family, okay, and is the sole earner of that family, okay, so has some kids, has dependent parents and stuff, okay. So at that particular time, in the age, let's say 25 to 30 years, the person may not be earning a lot of money, okay. So the amount of money that the person could invest or put as a premium might be less, okay. But if that person dies, because the person was sole earner of that particular family of, let's say, 5 or 6 or whatever, that would be financially a very big blow to that particular family. Correct? It might take a long time for that family to recover. Okay. So what happens is the benefit in this term assurance is high for a low premium. Okay. Now, why would benefit be high for a low premium? This is just basic mathematics when we calculate, because usually this term assurance is taken by people who are at a lower age. Okay, let's say a person who is age 25 takes this policy for next 20 years. So from age 20 to 20, so let's say 25 to 45, if the person is going for that age for this term assurance policy, the chances of a person dying at that particular age due to health problems, due to some diseases, is very, very less. Correct? So anyways, probability of a person dying at that particular age is very less. So because a lot of people would be paying premium and only a few people might be dying at that particular age, the benefit for those people would be very high. Okay. Now, would you be interested in such a policy in which the chances that you might get the money is very, very low? So there is a chance for 20 years we would be paying the premium, but there is no returns. You might be thinking, why would somebody buy such a policy, right? You would be paying premium for 20 years, but there would be no returns. Think about it in this point of view, that if you keep a security guard at your house and there is no theft, would you pay that security guard? I would say the security guard did nothing. The security guard was sitting there and nothing happened. There was no theft. He did not have to do anything. So why would we pay the security guard? Why do we pay the security guard? Right? Yes.
So like, because it is basically a safety kind of thing. Like,
Yes.
ho gaya, so if it doesn't happen, then it is good. But we are just taking a backup thing, like, to minimize the event,
risk.
basically.
Yes, minimize the
Yeah.
risk. So the main purpose of security guard is to discourage somebody. If somebody wants to steal, that security guard will discourage, right? So of course that does not happen in terms of term assurance, but it is the security that is being provided, because there is an uncertainty, and because if the person dies, even though probability of dying is very, very small at that particular age, if the person dies at that particular time period, there will be a big loss to the family, and because then the insurance company would provide financial support to such families for that security, the peace of mind, the you will say the risk that you are taking by going out every single day. There can be accident is one of the largest reason of dying at this particular age, because usually diseases and other health problems are very less at this particular age. Okay, usually it is the accidents that has the major reason for the death at this particular age. So what happens is there is a security, because you won't have to worry about what might happen after that. Correct? So the reason for term assurance is security, not investment. Okay. Whereas in pure endowment, the purpose is investment. So if you're feeling that after a certain age you need a certain amount of money, you would put it in pure endowment. So the reason is investment. After a certain age, you require a certain amount of money, put it in pure endowment. So let's say I know that I'm putting in money so that I can buy a house after a certain age. So let's say after age 55 I want a house, so I'm putting in small amount of money till that age 55. Let's say there is no family, there's no dependence. Okay, so I don't need that money if I am not around. So what I will do is I'll put it in pure endowment. Usually that is not the reason why people put it in pure endowment, but my target is that I will buy a house of, let's say, 20 crore rupees. So I will buy a pure endowment policy of 20 crore rupees. Whatever premium comes every single year, I will be paying off the premium. If I survive till that time, I'll get that money and I'll be able to buy my house. Otherwise, okay, if I don't survive, then no money and I won't be able to buy a house, no problem. Okay, usually that is not the case. Usually people have family, people have dependent people. So if I'm investing money, I would like to have returns in both cases. In both cases, if I want investment to be returned, I will be taking an endowment policy. So people take endowment policy for security, because if death occurs before the time, then the benefit is paid, and if the person survives, then also benefit is paid. So this is security plus investment. Now, if there is a chance that you can get security as well as investment, why would we choose term assurance? What is the motivation of choosing term assurance?
The premium would be lesser.
Yes, because of the low premium. So the main reason a person takes term assurance at that certain age is, for a low premium, you will get a lot of benefit that the family might need. Okay. And the reason you are looking for a low premium, because at that age 25 or something, there might be a lot of expenses because the person is starting new family, the job is also very new, so the salary might not be very high. So you are looking for a low premium and a high benefit if death occurs. That is the reason you are looking for term assurance. Endowment policy, definitely the premium would be higher. Rather, the premium would be addition of both of these premiums. So at the same age, if you calculate the premium for term assurance and premium for pure endowment premium will be much higher than a term assurance premium, and we'll be doing that. Okay. And then premium for endowment assurance will be addition of both the two. Okay. Then deferred, we said deferred, the benefit will start after certain times. Okay. So the reason might be, like, let's say I am planning to buy a whole life assurance policy, but let's say I already have a term assurance policy till age 60. Okay. So what I will say is, let's say I'm starting my whole life assurance policy today because I have some extra income that I can invest in. Okay. But this whole life assurance policy, I will start the coverage after age 60. Okay. Why? Because chances, the probability of dying between that age, let's say, 30 that I am today till age 60 might not be very much. So probability of dying is very low. And after age 60, I do not have any term assurance, so I am looking for a whole life assurance. So what happens is, because I have deferred my policy for these 30 years, but I'm still paying premium for those 30 years. So overall, what I might see is reduced premium. Reduced premium. Okay. or maybe some kind of some tax benefit. Okay, because today I would not have to pay a lot of income tax on that policy, because usually we get a certain amount of exemption in insurance policies, especially life insurance policies. So the reason might be because of tax benefit. I'm paying premium early and the premium amount will become lower because I'm paying a lot of premium, right? Of course, we will understand how do we calculate all of these things, assurances as well as premiums, because as we discussed before, what happens is our income as insurance company will always be premium, and our expenditure is the benefit that is paid. Okay, we will be talking about all of these assurance contracts and how we will calculate the benefit, how much benefit is paid, how much cost does the company incur. Okay, but in this we don't know how many premiums would be paid because we don't know when the person might die. Okay, so because of time of death is unknown, present value of premium and present value of benefit cannot be calculated. Right? So what we do is we take expectations, we take the probabilities of death in future. So what we do is we calculate expected present value, or I'll just write EPV of premium and EPV of benefits are calculated. What is EPV? It is expected present value. Okay, expected present values are calculated. Okay, now we'll learn how do we calculate expected present value. So whenever we are talking about assurances we'll take in terms of benefits. Okay, so we pay benefit in those assurances. So let's talk about how to calculate the expected present value in all of these cases in terms of benefits or in terms of assurances. Okay, so let's talk about whole life. Okay, before we talk about this, we'll say benefit is paid. We'll always take into account two types of payments. We will say at the end of year of death or immediately on death. Okay. So at any given point in time, if a person dies, if a policyholder dies, the payment can be in two forms. Now, in real life, what happens is when the family puts in the claim, it takes a certain number of days, usually about 30 days to let's say 15 days to 3 months it will take for the company to process, and within that time they will pay the amount. So let's say 15 days to 3 months is the time usually, after which the after death the family gets the money. Okay, but for calculation purposes, that is not how we will be calculating. We will be calculating either the payment is given at the end of the year of death, that is easier to calculate, or immediately on death, that is more close to the actual value. Okay, so either we will be assuming that the payment is given immediately on death, Okay, or we will be assuming that the payment is given at the end of the year of death. End of the year of death, easier to calculate. Immediately on death is more closer to the exact answer that we get. Okay, so of course, because we don't know the time of death, we will take the probabilities from our life tables. What had happened before, we will be trying to figure out using that what would happen in the future. Okay, so let's talk about whole life assurance. We'll talk about whole life assurance. First, we will take the benefit is paid at the end of the year of death. Okay, so I'll write at the end. Okay, it is at the end of the year of death. In this, we are saying benefit. Okay, for calculation purposes, we are taking 1 unit. So rupees 1 or whatever you want to write. Okay, benefit of rupees 1 given at the end of year of death, we'll say to a life aged X. So we are saying the life which is insured or assured is aged X right now, and the benefit of 1 is given at the end of the year of death. Okay. So in this, we'll say we have something kx. Kx is nothing but the number of years a person would live after age X, and then we'll calculate how much present value we will see in this particular assurance. Okay. So simply, if the person dies within the first year, okay, so between age X and age X plus 1, if the person dies within the first year, that is kx will be equal to 0, survive for 0 number of years. Then the payment would be given at the end of the year of death, that is here, and the present value will just become V. If the person dies within the second year, okay, that means our kx will be equal to 1. Person survived for exactly 1 year and died within the next year. Then the payment would be given at this time. That means present value becomes V square. Similarly, if the person dies within the third year, kx will be 2 and present value will be V raised to 3, because payment would be given at the end of the year of death. Right? Similarly, if the person dies between age X plus K and X plus K plus 1, that means survived for K years. So the present value, you can see the present value would be V raised to K plus 1, 1 more than the K value that we are taking. So we say our present value will be equal to V raised to Kx plus 1, where Kx can be anywhere between 0, 1, 2 till infinity. Okay. So we calculate expected present value. So we know the formula for expected value of X is just expected value, is just addition for all values of X, X into probability X is equals to the value X, right? This is our formula. So our expected present value is now a variable. It is a variable that is dependent on this kx variable. So it is sort of a function of this variable kx. Okay, so we can directly take kx probability. So this will become nothing but summation for all values of k, so k going from 0 to infinity, we will have v raised to k plus 1, okay, that is present value, into probability of kx being equal to k. We studied this in the previous, what do we say, previous chapter, probability of kx equal to k. That is v raised to k plus 1 kpx into qx plus k, surviving for k years and dying within the next year. Okay. And we write it as a symbol of capital AX. Capital AX is summation k going from 0 to infinity v raised to k plus 1 kpx qx plus k. Okay. Capital AX is expected present value of whole life assurance whole life assurance, okay, life assurance where sum assured, as I said, benefit is also called as sum assured, okay, sum assured of 1 is paid at the end of year of death. Is that clear? Now we calculate variance. To calculate variance, we require expected present value whole square. So first of all, variance of x is expected value of x square minus expected value of x the whole square. We have already calculated expected value of x, that is our ax, but expected value of x square, formula for that is summation for all values of x, x square into probability of x. So we will calculate expected present value square. Okay, expected present value square, we'll just square the present value. So present value was v raised to k plus 1, so v raised to 2k plus 1 into probability kx is equals to k. That gives us summation k is equals to 0 to infinity v raised to 2k plus 2, or actually I'll put bracket 2k plus 1 kpx qx plus k. Here what we'll do is we'll put v square as v dash. If we put v square as v dash, we'll get 1 plus I square is equals to 1 plus I dash, and I dash becomes 1 plus I square minus 1. Okay, 1 plus I square minus 1. If I do that, I get summation k going from 0 to infinity. I get v dash raised to k plus 1, probability kx is equals to k, right? So that is nothing but our AX but at a different rate of interest. AX at a different rate of interest. So we write this as AX at the rate of I dash, this I dash being this. And we have a symbol for that too. We write it as 2AX. Okay, we write it as 2AX. Our variance of present value will be equal to expected present value square minus expected present value whole square. Okay. So variance becomes 2AX minus AX square. This is our variance. Okay. So question, using AM92 Ultimate, find the expected present value and the variance of a whole life assurance paying 10,000 at the end of the year of death to a life aged 45. So a person, policyholder who took a policy at age 45, the person is paid 10,000 at the end of the year of death, and we have to find the expected present value and variance using AM92 Ultimate Mortality. One more thing, I will be writing I is equals to 4%. Now this AM92 table has two types of rate of interest, 4% and 6%. We can use 4% or we can use 6% to find values from here. Usually what happens is these are the two probabilities, these are the two rate of interest that we'll be using a lot in further questions. Most likely these are the two rate of interest that they will be giving you. Okay. So in our AM92 table, okay, we had AM92 table. If we go further, we will have Q values, we have mu values. When we go further, after mu values, we have EX values. Then if we go further, DX, we'll be using up to this capital DX. But after that, these NX, RX, SX, MX, these are not part of our courses. Okay, so NX, leave it, S, C, M, R, these are not part of our course. We will not be using them ever. After that, page number 96. Page number 96, on top you can see here we have 4%. As I said, bracketed values we will be ignoring for now. So these values we will be ignoring for now. And we have the values here. You can see capital AX and 2AX, right? Capital AX and 2AX. If you go down, you even have this value. So you see 2AX is equals to AX at 8.16%. Because if I calculate I dash, That was 1 plus I whole square minus 1 in terms of 4%. We'll see it is 8.16%. Okay. So they have calculated 2AX by putting 8.16% in AX. Okay. So we already have AX and 2AX values. So first of all, our expected present value will be equal to 10,000 into AX. 10,000 AX, A 45. 45. As I said, we'll be ignoring the bracketed value, so we are only concerned with non-bracket values. 45 age, AX value is 0.27605. So I'll have 10,000 multiplied by 0.27605. Then we can find variance as well. Variance would be, now see, whenever we talk about our variance for 1 was 2AX or 2A45 minus A45 square. But whenever we multiply anything, a constant value to the variance, the value, squared value comes out. So here we will have 10,000 square multiplied to it. This will be our variance. Okay. 10,000 square will be multiplied. Okay. Because here we had expected present value square. And when we had present value also, we took a square. Right. So in both the cases, 10,000 square will come out of those, and therefore we will have 10,000 square here. So 2AX minus AX. So 45, 2AX 0.09458 minus 0.27605 square. This into 10,000 square. This is our variance. This is our variance. Now variance in physical terms, see, expected value. What is this? This is the cost per person the company would be bearing. Okay, in terms of present value, that means in terms of today. Okay, so the company, if the company releases a whole life assurance to people age 45, okay, and assumes that the probability will follow AM92 ultimate and we will be earning at 4% rate of interest, then company would be bearing a cost of 2760.5 per person. Okay, per person to which we will be selling that particular policy. So let's say we are charging them premium today itself. Okay, pay the premium, one-time premium today. So we will be charging them at least 2765.60.5. Okay, this is the average cost that we will be bearing per person. What does variance tells us? Variance tells us that how much more or how much less are we going to get from that expected value. For that we require something called as standard deviation. Standard deviation is just root of variance. Standard deviation is root of variance. If I take root of this, I get 1355.955. No, 0.595. Okay. So we are saying the average cost that we'll be bearing per person is 2760.5. That is, let's say, the premium that we'll be charging, but it can go as high as, per person, the value can go as high as 2760.5, plus 1355.595. It can go as high as 4100, and it can go as low as this much, 1400. Okay. So we can expect cost per person to be as high as 4100 and as low as 1400. Okay. So if the cost per person is lying within that range, we will be happy about it, because sometimes what happens is, because we cannot predict if the person would live exactly the number of years that we have predicted, right? Because we are saying the person who is age 45 today might die anytime from this time times 0 to infinity, right? We have calculated the probability of that happening, but that does not mean exactly that is what we will be seeing. So because in past we saw that 2 people die in age 45 to 46, does not mean exactly 2 people will die at that particular age. It might be 3, it might be 5, it might be 0, right? But we are saying averagely this is how the probability goes. So we say if exactly what we had expected from the past data, what we had expected, these many people would die at that particular age. If that happens, per person, we will get this much cost. But there can be fluctuations in the probability. So it can go as high as this or as low as that. So we'll add or subtract. Okay. So we'll say average value, expected present value, plus or minus the standard deviation. This is our expectation. It can go as high as that much or as low as this much. Okay. So this is why we calculate expected present value as well as variance. Let's go to term assurance. Okay, term assurance. In term assurance, again we are talking about benefit payable at the end of the year of death. Okay. So we say benefit of ₹1 given at the end of year of death if IF, and I will put another F. When we write IFF, that just means if and only if. Okay. If and only if death occurs, if and only if death occurs within n years, okay, to a life aged X. Okay, to a life aged X. So in this we'll say it works exactly same as our whole life assurance, that is v raised to kx plus 1, if the death occurs less than within n years. Okay, so if kx is less than n, then the present value will be v raised to kx plus 1. But if the death occurs after n years, that means our kx is n or more than n, because kx is number of years a person survives. Okay, so if the person survived n years, that means the death occurs after n years. So then 0 payment is given. Okay, so then zero payment is given. Okay.
Sir,
Yes.
sir, can we take term assurance after age 60
Term
or like at
assurance.
any age?
I did not understand. After age 60 means age
Like,
60.
can we
Okay,
take it
okay,
at
okay.
any age?
See, what happens is the insurance company should be able to provide you with that type of policy. See, what happens is insurance company will only give you that policies which a lot of people might be taking. Okay. So first of all, they should be certain about things happening in the future. Of course, that they can very well calculate. But secondly, people that age must be willing to take those kind of policies. Okay. So I can make let's say 20 crore policy for let's say 5 year, 5 year old person. But what happens is the 5 year old will not never be buying a policy. Their parents will be buying, and then the parents might not be taking such a huge policy for such a small child, right? Because there is no reason for us to buy that, such policy for whatever reason, right? So the purpose should be very well defined, and people should be able to understand the purpose. So you as a company would like to sell that policy, right? So the people should be willing to buy your policy. So if at age 60 a person is already retired, the probability of death is high, so premium might be higher, right? So what happens is the person would say, why would I buy a term policy? I would be buying a whole life assurance in this particular case, right? Because of course the chances of dying, let's say within 30 years, is very high, but that is why the premium will be higher. And the person might have money to actually buy whole life assurance, right? Rather than term, the person might have money to buy whole life assurance. So because most likely the person who is age 60 might not be willing to buy such a policy, that is why the company would not be giving you such a policy. So usually term assurance policy is bought at age from, let's say, age 20 to 45. Okay. You can definitely buy it at age 60 if the company is giving you. Most likely, yes, they will be providing you a policy, but the premium becomes higher and chances that people will be buying such a policy is low. Okay. See, usually what used to see, there's a big difference in what used to happen and what today happens in companies. I'll tell you the big difference. A few years back, what used to happen was company used to give you a certain chart in which let's say if you are selling policy, if you are an insurance agent going to people to explain them what kind of policy it is, and in that chart there used to be an age factor, at what age you are and how much premium, how much first of all term you can get. So let's say at age 40 you can get a term policy of 40 more years. Okay. And how much premium you will have to pay. Okay, age 40, then age 41 they will say you can buy 39, age 42 you can buy 38, and of course premium will start increasing. Okay, so that ways they will have a chart. So they will say, let's say we will restrict it to age 59. Okay, a person age 59 would, after that, would not be buying. So accordingly we will say the, I think 31 comes out, or no, 21, right? And whatever premium might there be. Okay, so there used to be such a chart. So the company used to decide that we are willing to sell a policy to certain age group only, and the term would be set this much. So again, a person who is age 40 might not be actually buying 40 years of term, might be buying only for 20 years. Okay, so for that they will have to have different policies, correct? So a policy would be, let's say, ranging from certain term to certain term, or certain age to certain age. Okay, so I might make a policy where I will say, for a fixed age, if you buy a term of 10 years, 15 years, 20 years, or whatever, you will have to pay premium this much, this much, this much, age 40, then age 45, this much, this much, this much, like that. Okay, so there used to be so many different factors that you will have to deal, and then you will have to sell a certain number of policies. So the company used to restrict a certain number of policies, correct? But nowadays, because everything is online, you can literally go to companies' pages and you can fill whatever information you want to, age, gender, maybe some diseases or whatever. What kind of policy do you want? How much term do you want? And they will generate, computerized everything, and they will generate the premium for you. Okay. So few years back, but when everything was done on calculators and on papers, it was difficult for them to give you any options, right? So they had to restrict it for a certain number of options. But nowadays, because their computers can calculate stuff very easily, very fast, you just have to feed the formula in it. It is very easy, and now you might have a lot of options, but of course they will have some limitations. Okay, they realize after some age it might not be very feasible for the company even to maintain such a policy, and of course the customers might not be buying such a policy, so they might not offer you option to go above age 50, above age 60, or above age 70, or whatever, right? For certain kind of policies. Similar thing happens with health insurance policies as well. Health insurance, if you buy at a lower age, the premium would definitely be lower. But health insurance is given only for 1 year. Okay, every year you sort of renew your health insurance, and the premium starts becoming higher and higher and higher as your health becomes higher. But let's say if I start buying health insurance today, at age 60, at age 70, even though premium will be higher, they will not refuse me health insurance, because I have been a customer for past 30 years. They know my habits, they know my history of any illnesses and everything, right? So for them, I am a good bet, because they understand my health. Even though my health might not be very good, they know what might occur in the future, what kind of diseases I am suffering from. That is why what kind of hospitalization, or what kind of surgeries I might require. Versus if a person age 60 wants to buy a health insurance at that age, they might not offer them. Rather, a lot of companies stop at age 45 or maybe 50, or the limit is usually 60. Okay. If you want to buy health insurance after that, you will have to go through a lot of checks to make sure that there is no such big diseases for which they might have to pay a lot. Okay, so what is happening is there is a big uncertainty for them at that higher age, and where at least there is a certainty that they might have to pay very soon. So either they will be charging you a lot of premium that might not be advisable, or at least it might not be very attractive to a customer, or secondly they might not, or they might feel like there is a big chance of loss in that sort of policies. Okay, so of course the company is not doing charity. The company wants to make profit, wants to earn money out of it. That is why they are giving us such policies, right? So if they feel like it will not sell, they will not make such policies. Okay, so today you might find term policy for age 60. I don't think why not. Okay, they will sell you such policies if you are willing to buy at a higher premium. In future, what I will do is I will find such a good website where we can see different policies, and I'll show you how things change. Okay, so again, where were we? We were talking about term policy, present value, right? We said that if the person dies within those n years, okay, then the value is paid, therefore present value becomes v raised to k plus 1. And if the person does not die within those n years, then nothing is paid. So therefore my expected present value becomes summation k going from 0 to n minus 1, v raised to k plus 1, probability kx is equals to k. That would be v raised to k plus 1 kpx q x plus k. We write it as a symbol a x dash n. Okay, that dash is basically 1. I just have a habit to call it as dash. You can write it as 1 or just put a dash, does not matter. Okay, so x is age, n is the number of years the policy is going for. Okay. So again, a represents assurance, okay, expected present value of assurance. I'm just writing it as assurance. X represents age at which the policyholder is. N represents the term of policy. And this dash represents type of policy. In this case, it means term assurance. This dash represents type of policy. Okay. So for calculating expected present value square, to calculate the variance, I'll just say that becomes summation k going from 0 to n minus 1, v raised to 2 k plus 1, probability kx is equals to k. Okay. So again, if I write it in terms of I dash, so this is same as summation k going from 0 to n minus 1. So v dash k plus 1 kpx qx plus k. So I can write it as a x dash n for rate of interest is I dash, or you can write it as 2a x dash n. So variance of present value just be 2a x dash n minus a x dash n whole square. Now while we are studying this chapter 16, chapter 17, we will also be studying chapter 18 together, because chapter 18 is just relationship between all of these. Okay, so we will be doing it with chapter 16 and chapter 17 itself. Okay. Term in terms of whole life. Now we know our ax dash n is summation k is equals to 0 to n minus 1 v raised to k plus 1 and into probability k is equals to k, kx is equals to k. We know for whole life whole life, our AX is summation k going from 0 to infinity v raised to k plus 1 into probability kx is equals to k, right? For whole life, this is what our formula is. The only difference is in whole life we are going from 0 to infinity. In term we are going from 0 to n minus 1.
Sir, a doubt, sir.
Yes.
So we're going till n minus 1. Even if the policyholder survives between the term n minus 1 and n, we should pay the benefit, right?
Yes, definitely. So see,
Then why?
yes, n minus 1, this is the doubt, right? So k is number of years a person survives. So when we say k is going 0, when we say k is 0, that means the person survives 0 number of years and dies within the next year. That is dying within the first year. When we say k is equals to 1, survives 1 year and dies within the next year, that is dies within the second year. So when I say n minus 1, that means survives till n minus 1 years and dies within the next year. That means dies between n minus 1 and n. If I write k is equals to n, that means survived for n years and died between n and n plus 1. There should be no payment at that. Right?
Okay, sir.
Okay. So now here, I can say this is nothing but summation k going from 0 to n minus 1 v raised to k plus 1 kpx qx plus k, and now I will just add and subtract the rest of the value to make it infinity. So I'll say k going from n to infinity v raised to k plus 1 and kpx qx plus k. Okay. So if I just take the addition one, I'll get summation k equal to 0 to infinity v raised to k plus 1 kpx qx plus k, and then I'm left with minus summation k going from n to infinity v raised to k plus 1 kpx qx plus k. Of course, here this is nothing but ax. This part is ax. But for this, what I will do is, if I want to make it in terms of ax, I should be going from 0 to infinity. So I will introduce another variable here. Instead of k, let's say we'll write m. M is equals to, we will take k minus n. Okay. If I take m is equals to k minus n, what do I get here? My m is going from 0 to infinity, right? Because when I put k is equals to n, m is equals to 0. When I put k is equals to infinity, m is still infinity. So m is going from 0 to infinity, and now I will substitute k is nothing but m plus n. So v raised to m plus n plus 1, m plus n px q x plus m plus n. Now we know that our m plus n px can be written as npx mp x plus n. Okay, and here also v raised to n, I can take it outside. These are constants. So let's say ax minus v raised to n npx outside, and I will have going m is equals to 0 to infinity v raised to m plus 1. We'll have mp x plus n, and write this as q x plus n plus m. Now if we compare this to our original formula, that is this, instead of k we have m, instead of k we have n, and instead of x, going from age x, we have x plus n, going from age x plus n. So this becomes ax minus v raised to n NPX A x plus n. This is our formula for A x dash n, term assurance. Very important formula. We'll be using this a lot. Now, of course, if here I want to write it in terms of 2 and stuff, I can change the rate of interest. If I say my AX dash n at the rate of I dash will be equal to what? A x at the rate of I dash minus V dash raised to n, NPX, and A x plus n at the rate of I dash. This at the rate of I dash can be written as 2ax dash n, a 2ax, but this v dash is what? R. Again, if you want to write, our v dash was v square, and therefore I dash was 1 plus I square minus 1. Okay. So this becomes 2ax minus v raised to 2n, NPX 2ax plus n. Variance then, it's 2ax dash n minus ax dash n whole square, right? This we have, I think, already written. Just give you a question. Again, we are going to use AM92 ultimate and rate of interest as 4%. Okay. We're saying find expected present value and variance for a 20-year term assurance policy paying 10,000 at the end of the year of death of life aged 45. Okay. So we know the term 20 years, we know what our age is 45, so it's a expected present value must be 10,000 A 45 dash 20, okay, A 45 dash 20 will be equal to, according to this, what do we get? A45 minus V raised to 20, 20P45 A. Then we will add 45 plus 20 gives us 65. Now what is this saying? Whole life assurance to a person who is age 45, but if the person survives for 20 years, right? Discounting for 20 years, and if the person survives for 20 years, then subtract the future whole life assurance. Future whole life assurance was going to be A65. So we're subtracting the future whole life assurance if the person survives for 20 years. So we know A45, we know A65. We can easily find that from our tables. So again, AM92, we are talking about 4%. Okay, so same page. Here A45 is 0.27605 minus, okay, V raised to 20, 20P45, I will talk about that later. First, let's write A65. A65 is 0.52786. Okay, multiplied by, we want V raised to 20, 1.04 raised to minus 20, and then multiplied by 20P45. We know 20P45 must be L x plus n. X plus n becomes 65 upon L 45. So L 65 upon L 45. This we have to take from AM92 tables only. At the beginning of this AM92 tables, we had L values. Okay, so we will go up, okay, and we'll go to the AM92 table L values. Always remember, we will have L, D, Q, then I think mu, E, and then whatever later. So L65 is here. We'll have 8821.2612 divided by L45. L45 will be here, 9801.3123. This becomes 0.0592305. We'll multiply with this with 10,000. So expected present value comes out to be 592.304. So you can see for term assurance of 20 years, for a benefit of 10,000, the total premium, one-time premium comes out to be 592. So almost for 600 rupees, you can clearly see for a person age 45 can buy a term assurance of 20 years. Because even between this age 45 to age 65, the probability of dying might not be very high. Okay. So that is why the term assurance is very low. So you can imagine, if I want to, instead of 10,000, I want a 1 crore policy, I'll just multiply by, I think, 3 more zeros. Okay. So it will be a certain amount. And if the age was lower, if we were talking about person age 20 to 40, the premium will be even lower. The cost that the company have to bear would be even lower. And here we are even talking about one-time premium. This would be the one-time cost. This is the amount that the company would charge as a one-time premium. Okay, if you are dividing it over a lot of number of years, you will get smaller premium than that, right? So if you are paying this over, let's say 10 years, so it will be almost 10, or it will be less than 10 because of present values and stuff, right? So premium becomes smaller. So this is our expected present value. For variance, we'll calculate 2A 45-20. We'll take 2A 45 minus V raised to 40 20P 45 2A 65. So again, we will require this L65 and L45. Rather than going down and again up, I will first write this. So I'll say minus 1.04 raised to minus 40 into this value. I will just write down L65 was 8821.2612 and 45 I have 9801.3123, and then multiplied by, we will say 2A65. Let's go to assurance table. So we have here assurance table 4%. First we want 65 is given here. 2A65 0.30855, and then plus I want assure to 2A for age 45. 2A for age 45 would be 0.09458. Variance, we'll say 10,000 square to A 45-20 minus A 45-20 whole square. Okay, so 10,000 square to, this is 0.03686 minus this value was 0.0592345 square. So variance is 3323035.37. You can even represent that as, first find the root and write it as 1822.919 square. You can write it like this as well. Okay. Usually, because as we discussed, standard deviation is what we use in our further understanding what might happen. So you can write it like this as well. Okay. Both of these answers will be accepted as correct answers, this as well as this. Again for AM92 ultimate 4%, find A 25 20. You can find this. Also find 2A 25-20. Find this and tell me what these values are going to be. I will be back in 2 minutes. Okay, so what is the value that we are getting? First of all, this is going to be A25 minus V raised to 20, 20P25, A 45, right? So are we all getting 0.00980211? For this 2A 25 V raised to 40, 20P 25 and 2A 45, value is 0.006631,455. So you can see if I multiply 10,000 here, I will get still just 98.0211. So if a person age 25 takes a term assurance policy of 20 years for 10,000, you can see such a small price, whereas person from age 45 taking for the next 20 years had to pay 600. You can see such a big difference. So as the age becomes less, probability of death becomes less, and that is why the company has to pay less number of people, and therefore the premium is also low. Okay. This is the reason that we were talking about, that people prefer term assurance policy. Okay. So you can imagine if I have to pay such a small amount, I might pay larger amount to get larger returns. Okay. So I can take a, let's say 1 crore policy or maybe 10 crore policy for a very small amount. Or I may go for a larger term, maybe for 40 years. Okay. Same thing. So then the premium starts becoming a little bit more. So this is a term assurance. Okay. Next we'll talk about deferred whole life assurance. Okay, we'll talk about deferred whole life assurance. So as we talk about deferred it's a whole life assurance, but it is deferred. It is starting after a certain number of years. Okay, so here we say benefit of ₹1 given at the end of year of death if death occurs after n years. Okay, so only if the death occurs after n years, then this payment is given. Okay, so here present value is going to be, the payment would be 0 if the death occurs within those n years, and the payment will be V raised to kx plus 1 if the death occurs after n years. Right? So it is exactly opposite of term assurance, right? and we say the payment would be given only if the death occurs after n years. So it becomes whole life if the person survives n years. Okay, so it becomes whole life only if the person survives n years. So if I want to discount here, I will be discounting with v raised to n, and I will also be multiplying npx, that means probability of surviving. Okay. So in our life assurance, you will be seeing that almost every time whenever we are discounting, we are also multiplying with npx. Okay. We are always saying if the person survives for n years, then we will be doing this. Like here also, we had v raised to 20, 20px. Okay. So our expected present value becomes our whole life assurance, but starting after n years, x plus n, and before that we will be saying discounting for n years, and if the person survives for n years. So if the person survives for n years, then a whole life assurance starts. We can also write it as n deferred ax. So ax represents that there is an whole life assurance for a person age x today, and we are saying it is deferred by n years. Okay, it is deferred by n years. So again, n deferred 2ax would be v raised to 2n npx 2ax plus n, and variance will be n deferred 2ax minus n deferred ax whole square. So if we see, we use this to find a term assurance. Okay. So we can actually say our whole life, okay, present value of our whole life was equal to present value, I'll say WL whole life. It was nothing but present value of term plus present value of deferred. Okay. So that is how we got our expected present value of term formula. Okay, so you can say expected present value of whole life will then be expected present value of term plus expected present value of deferred, and therefore expected present value of term was expected present value of whole life minus expected present value of deferred. This is how we made that formula. Okay, this is a simpler explanation. So therefore we said a x dash n was ax minus v raised to n npx ax plus n. This is what our deferred is. Let's take pure endowment. Again, benefit given at the end of the year of death. But in pure endowment, we do not consider the death part. In pure endowment, we consider if the person survives. So we'll say benefit of rupees 1 given at the end of n years if the policyholder or the life survives. So if the life survives, only then the payment occurs, and that too at the end of n years. So we say our present value will be equal to 0 if a person dies within n years, and if the person survives n years, then the payment is going to be v raised to n. Exactly at time n the payment would be given for anybody who survives more than n years. So our expected present value will be equal to v raised to n into probability. Our kx will be greater or equal to n. That is nothing but npx. We did that in chapter 15. We'll have v raised to n npx. We write this as a x n dash. Okay, a x n dash, or 1 if you want to call it as 1. It just, we were talking about ax dash n. This was nothing but term, and ax n dash is pure endowment. Okay, so here dash was over x because we said the payment would be given if x, that is life, ends before n. So you can say life ends first, then the payment is given. Here we are saying that n ends first. That means the term ends first. If that happens, then the payment is given. So if the person survives those n years, then the payment is given in pure endowment. That is why 1 is for that ending first. Okay. So either life ends first, then term assurance, and if the payment is given on the term ending, then we'll call it as pure endowment. Okay. 2a xn dash will just be v raised to 2n npx, and variance will just be 2a xn dash minus axn dash whole square. Okay, you can easily solve this. You will be saying here you have v raised to 2n npx minus here this squared, so this will be v raised to 2n npx square. If I take v raised to 2n npx outside, common, get 1 minus npx, that is nqx. So this just becomes v raised to 2n npx nqx. This is what the variance is. You don't need to remember this. You can solve it, or you can solve it like this, no problem. This is pure endowment. And we'll talk about endowment. Endowment is just term plus pure. This is what our endowment policy is. So we'll say present value will be, if the person dies within n years, then it is v raised to kx plus 1 if kx is less than n. And if kx is greater or equal to n, that means if the person survives those n years, then the payment would be exactly at time n, that is v raised to n. We will just, for expected present value, we will just add the expected present values of both. So k is equals to 0 to n minus 1. We'll have v raised to k plus 1, kpx, qx plus k, plus v raised to n, npx. We write this as a xn without any dashes, because the payment is given when the person, if life ends before n years, then the payment is given, or if n ends before life, even then the payment is given. Payment is given in both cases. So payment can be given anywhere from time 0 to time n. So our AXN will be A x dash n plus AXN dash. I usually directly write it as AX dash n plus v raised to n npx. Okay, directly do this. This is second way of finding our term assurance. I'll show you later on what does that mean, how we can use this. Okay. Then variance. Okay, first of all, I'll just write variance. If I want 2ax n, we know it would be 2ax dash n plus v raised to 2n npx. Variance will just be 2ax n minus ax n whole square. Okay. Let's find A 45 20. Okay. So A 45 20, again we'll use AM92 ultimate for 4%. Okay. So for that we will be saying that would be A 45 dash 20 plus v raised to 20 20p45. If I want to find this, I'll say it is A 45 dash 20. We'll have A 45 minus v raised to 20 20p45 A 65. So I'll require this v raised to 40 v raised to 20 20p45 two times. So I will calculate this separately, v raised to 20 20p45, so that we can use it two times. So let's first find v raised to 20 20p45. So L65. So first of all, I'll say 1.04 raised to minus 20 into L65. That would be 8821.2612 by L45. L45 would be 9801.3123. 0.410751 okay. I'll use this to find my term assurance. From this point on, we'll be using this table book for every single question. So you should be very good at using the table book and not make mistakes. So at the beginning, we'll definitely make a lot of mistakes. We just have to make sure that we do it while we are practicing, not in the examination. Okay, so AX for 45, 0.27605 minus, I will take answer, that is our V raised to 2020p 45 into, we want A65. A65 would be 0.52786. Okay. So what would be this? This much plus 0.4107519. So for every 1 rupee that we would give as a sum assured, it will cost us 0.469. Okay, 0.469 would be the cost for an endowment policy for certain age. This is what the age we are talking about. So you can see out of that, pure endowment is the major part. You can see 0.469 out of that 0.41 is just pure endowment, and only 0.059 is the term assurance. Right? So term is almost very, very low in this situation. So that is why we were talking about the term assurance premium is very small and the benefit is large. Versus endowment, of course, it's better than term, but definitely premium will have to pay much more. Correct? Any problem here? Of course, you can calculate 2A and stuff also here. Okay. So just tonight, before you sleep, just read all of these. Just write down the formulas in one place so that we can use it tomorrow and we don't get confused. Okay. So write down all the formulas at one place so that we are not confused tomorrow. Okay. Tomorrow morning, 8 a.m. we will continue and we are going to see more questions or more different types. Okay, so what happens is from here confusion becomes larger because we are going to study a lot of different types, lot of different formulas, and we get a lot confused in all of those formulas. So therefore I want you all to keep your formula sheet ready and updated every single day. Okay. So let's end our class here and we'll meet tomorrow morning.
Thank you, sir.
Welcome. Bye.